Alright guys, so I'm going to quickly go through the PowerPoint on circuits to explain. So this slide talks about just review definitions on the electric charge and electricity. Okay, so we know objects become positively charged when they lose electrons and they become negative when we gain. We also know that opposite charges attract and like charges repel. And electricity is the presence or the flow of those electric charges. Okay, so in circuits, you guys did the physics classroom concept builder on determining which diagram would cause a lit bulb. Okay, so you drew those three diagrams from that question that you guys had to answer after the activity. We had a wire, we had a bulb, and we had a battery. Okay, so now you see the schematics that we're going to use when we're talking about circuits in this unit. So I want you guys to go and instead of drawing an actual battery, you're going to use the first picture here to symbolize a battery. Okay, for a regular wire, you're just drawing straight lines to connect it to the bulb. And you can use either picture, but the most common one for the bulb is the one with the X in the middle. Okay, so you will have a battery, you would draw a line, two lines to connect it to the bulb. So it looks like a rectangle or a square. Okay, and then you're going to label. So you'll label your battery, your wires, and your bulb. So one of those diagrams was a closed circuit. So closed circuit are complete, okay, and we can have electrons flow through them. So the one that would have been the closed circuit would have been the answer, which was the middle picture. Why? Because all components are within the circuit, everything is connected. So the electrons can flow from the negative end into the light bulb and then out the light bulb to the positive end, and it keeps going. The other ones were broken circuits. As you can tell, the light bulb would not light up. Okay? Those flow of electrons, we call them electric currents. And as I stated before, the electricity flows from the negative end and it goes to the positive end. So you see the direction of the current, you should go back and label your diagram showing the flow of the current. The circuit that we created has a DC current. DC stands for direct current. Okay, you may think it's direct because we have the wires touching the battery, and that's a good thought. But it's a direct current because we have one pathway that the electrons are flowing, one direct pathway. Okay, we normally use in everyday life, like when we plug in our appliances at home, we use an AC current, which stands for alternate current. And that means the direction of the current changes back and forth at a certain time. Okay, so we need three basic parts to a circuit. We need an energy source, we need the wire, and the load. My question is, what material do you think the wire needs to be made out of? Some type of metal, something that conducts electricity very well. So you will have like a copper wire or any type of metal. Okay. Looking at the picture, we have the light bulb is also called the load. Okay. And the load is just the object that's going to change that electrical energy from the wire into another form of energy. In this case, the light bulb is using the electrical energy to create light energy or even a little thermal heat energy. Okay, so you can go back to your diagrams that you drew and just also label. Energy source is my battery. The light bulb is also called the load. Okay. Okay. So now we're going to get more specific